Nuclear fission. It is something incredibly small but creates one of the most powerful reactions. It powers cities, drives submarines, and has changed the course of human history. But what really happens when an atom splits? And how is it different from nuclear fusion? Welcome to Explore Science with Teraj. Today we are going to explore the tiny but a powerful world of nuclear fission and understand the difference between nuclear fission and nuclear fusion, and also learn about its historical invention. Nuclear fission is the process of splitting a large atomic nucleus into smaller nuclei. This usually happens when a heavy atom like uranium is hit by a neutron. When it splits, three things happen. Number 1, energy is released. Number 2, smaller atoms are formed. And number 3, more neutrons are released. That energy comes from a tiny loss of mass, explained by the mass energy equivalence, which states that even a small amount of mass can produce a huge amount of energy. By the way, if you want to know more about this mass energy equivalence, please check out our detailed video in our channel. Link is in the description. Atoms are considered stable or unstable based on the atom's capacity to handle its electrons. Let's take an example. Uranium-235 is a heavy but stable atom that contains 92 electrons, 92 protons and 143 neutrons, whereas uranium-236 is a heavy and very unstable atom that contains 92 electrons, 92 protons and 144 neutrons. By this time you would have done the math. The only difference between them is that one neutron, and that's all we need. When a neutron produced during an exothermal reaction, basically a spark, collides with this uranium-235, it becomes uranium-236, which is very unstable. It splits into krypton isotope and barium isotope, which is stable. But during this split, an enormous amount of energy is released. The extra neutrons released can hit other atoms, causing them to split. This creates a chain reaction. If controlled carefully, it produces steady energy. If uncontrolled, it releases energy extremely rapid. And this is the core idea behind both nuclear power and nuclear weapons. Nuclear fission is used to generate electricity. The heat produced is used to boil water, create steam, and spin turbines. This electricity powers millions of homes. We know very well that there are no refueling stations in the middle of the sea, and this makes refueling very difficult for ships traveling long distances and especially submarines who are under the water surface for months. So they use nuclear fission for this cause. Nuclear fusion reactors provide long-lasting energy without needing frequent refueling. Well, if nuclear fusion is controlled, we can produce stable energy, but in this case, the chain reaction is uncontrolled, releasing enormous energy in very short time. Well, actually, I'm planning to upload another video on the working of atomic bombs, so let's not dive deep in it. Nuclear fission is often compared to nuclear fusion, but let's break it down. Nuclear fission splits large atoms, it is easier to achieve and is used in today's power plants, but produces radioactive waste. Whereas nuclear fusion combines small atoms, it's harder to achieve and powers stars like the sun and produces less waste. Let's make it easy to understand with an example. As we saw, nuclear fission happens when we split the uranium atoms into smaller parts to release energy. Nuclear fusion takes place when we combine few atoms. For example, the sun and the stars. Every star in the universe shines because of nuclear fusion. When hydrogen nuclei fuse together, they form helium and release energy. That is exactly what happens inside the sun every second to produce sunlight. Without this nuclear fusion, there would be no light, no heat, and no life. Fission and fusion do not only happen in nuclear science. it happens in daily life. For example, a unicellular organism called amoeba reproduces through a process called binary fission, where the parent cell divides to form two daughter cells. On the other side, the production of thermoplastics includes fusion of polymers. But why is nuclear fusion so difficult? Here is the challenge. Atomic nuclei are always positively charged, so they repel each other. To force them to fuse, we need extremely high temperatures, that is millions of degrees, and enormous pressure. Basically, we need to recreate the conditions like the sun, right here on Earth. That's why fusion is one of the most difficult engineering challenges in science. So the simple difference is nuclear fission equals breaking apart and nuclear fusion equals joining together. Both of them release energy, but in different ways. Nuclear fission was discovered in 1938 by Otto Hahn and Fritz Strassmann. But it was Lise Meitner who explained what was really happening, that the atom was actually splitting. This discovery changed science forever. Soon after, during the World War II, fission research led to the development of nuclear weapons, significantly the atomic bomb. But later, scientists realized it could also be used for peaceful purposes, like generating electricity. Nuclear fission shows us something incredible. Even the smallest particles can hold enormous power. But humans turn every discovery into disasters. Well, that's human nature. But thanks to few scientists, we have transformed that disaster into a new source of energy. If you enjoyed this explanation and learned something new from this, please like the video and subscribe to Explore Science with Teraj. Because science isn't just about facts, it is about understanding the forces that shape our world. See you in the next video.